homework last night, worksheet number 2, questions 1 to 4. We're going to go over questions 2 and 3 right now. Question 2 says, light travels at an incredibly high speed of 3 times 10 to the 8 meters per second, 1 billion kilometers per hour, as we said. It's so fast that light would actually travel from Halifax to Vancouver and back again, if it could actually travel that far through the atmosphere, and if the Earth was flat, because it actually, even if it was really, really strong, it took off in Halifax and it's going to go off into the sky before it ever gets to Vancouver, right? But if it could travel from Halifax to Vancouver and back again, it would do that about 30 times, Halifax to Vancouver and back again, 30 times in 1 second. That's how fast light travels, 1 billion kilometers per hour. Anyways, this light travels at this incredibly high speed of 3 times 10 to the 8 meters per second. How far is it going to travel in 1 hour? We should write down our givens here. My speed is 3.00 times 10 to the 8 meters per second, and my time is 1 hour. I don't really want hours, though. I think I want seconds for this. So I'm going to have to convert this, first of all, from hours to minutes, and then minutes to seconds, right? Multiply it by 60 to get minutes, multiply it by 60 again to get seconds. Or what could you do if you wanted to take a bit of a shortcut? Just times it by 3,600 all at once, right? And do it as a one-stepper here. So my speed is 3 times 10 to the 8. My time is 3,600 seconds. I'm looking for my distance here. We know that v is equal to distance divided by time. Rearrange that. I get distance is equal to, how do I get rid of a t when it's divided? Multiply, right? So it becomes d is equal to v times t. V is 3.00 times 10 to the 8 times a time of 3,600. I think it was it Jack yesterday that showed me how to do this on the calculator? Showed us how to do this? If you want to enter the times 10 to the 8 thing, you use that EE button, second function EE button on the calculator. It's going to come up in just a second here. So we're going to say, for this one, it's 3 second function EE, 8, and then we're going to multiply that by 3,600. Gives us a value of 1.08 times 10 to the 12. By the way, if you, it depends on the mode your calculator is in. I'm not sure by default. It probably just says 108 and then a bunch of zeros. Okay, you can kind of trick your calculator into converting it to scientific notation for you. Just click on mode. Oh, I'm in normal mode here, actually. I guess that's such a big number. It's just such a big number that it puts it in scientific notation already for me. If it doesn't, you can trick it to put it into scientific notation by just going into mode and then clicking scientific and going out. Okay, 1.08 times 10 to the 12 meters. Is that the right number of significant figures? Is that the right number of digits? That is. Yeah, if we look at our data here, we've got 3 digits and we've got 3 digits. Final answer should be 3 digits. Yeah. Good? Oh yeah, let's take a look at number 3. Number 3 says the average braking reaction time for a driver is 2.3 seconds. You can also imagine if you're sitting there doing this, as you're driving, your reaction time is going to be much greater than 2.3 seconds, right? 2001 was before we had to worry about that. The velocity of the car is 90 kilometers per hour to the north. What's the displacement of the car during the time? How many of you guys did kilometers again? How many of you guys did meters? Okay, most people did meters. Okay, let's do it in meters then. What do we have here? My time interval is 2.3 seconds. My velocity is 90 kilometers per hour to the north. Let's define north as positive. Most of you guys said you use seconds, So that means we got to convert kilometers per hour to meters per second, right? We want to be consistent. If we got seconds for time, we need meters per second for speed here, or velocity. How do you do that? Remember the trick that I showed you yesterday, Tyler?
You multiply the kilometers, multiply the kilometers by 1,000.
Yep.
And multiply the time by 36.
Yeah, so you got to do two conversions here, right? Kilometers to meters, and then you got to convert hours to seconds. Kilometers to meters is 90,000 meters, and hours to seconds is 3,600 seconds. When we do 90,000 divided by 3,600, it gives me 25 meters per second. Now I'm looking for the displacement here. We're going to say displacement is equal to V times T, like we did in the last question. So we get 25 meters per second times 2.3 seconds. And that gives me a displacement of 57.5. Oh, wait a second. I get 57.5 meters, but what should the sig figs be? Let's look back to our data here. By the way, it doesn't matter what I have written down here, because I may have written down what it said in the question, or I may have rounded it or whatever. That doesn't matter. What matters is the original data in the question. I got 2 digits there, and I got 3 digits there. The final answer should be 2 digits, right? The least precise piece of data. The chain is only as strong as the weakest link. This is the weakest link of the chain, so we have to round it to 2 digits, which is going to be what? 58 meters. Right, that's my final answer. Good? Okay, let's do an example, take a quick little break, and then we'll come back and do some more stuff here. Example number 4. We did example number 3 yesterday. Let's finish off this topic with example number 4, and that'll allow us to do a couple more questions on your worksheet here. Example number 4 says, a hiker walks 300 meters to the east and then 1,200 meters to the west. The hiker takes 1,800 seconds. What's the hiker's average speed and average velocity? What do we have given to us here? Are these distances or displacements? These are displacements, right? These are not where the hiker is. This is how far the hiker has traveled. We got 2 different directions here, east and west. Which one do you want to make positive? West? West? Who says west? Who says east? About 50-50. Doesn't really matter. I'm going to make east positive since it's 50-50, and since I like making east positive, and I'm the teacher, so I get to decide. But in the end, if you make west positive, that's fine. If all of you had said west, that's the way I would have done it. There's nothing wrong with that. It just means that I'm going to get the opposite sign of an answer than you'll get if you said west is positive. All right, let's write down some givens here. By the way, A and B, we only have to write down our givens once, right? Once is fine. What do we have here? What's this 300 meters? Tell me what that is. Position, displacement, velocity, what is it? Time? Yeah, it's displacement. What displacement is it, though? Is it the total displacement? Yeah, well, let's call that displacement 1. I don't like saying initial displacement, because we can have like 4 or 5 different displacements there, and they all matter, right? With positions, it's different. Okay? We can say initial position, final position. Doesn't matter what happens in between there, right? It does matter for displacement what happens in between. So let's say first displacement is 300 meters. The second displacement, D2, will be 1,200 meters. Is that right? Yeah, we're going to make it negative 1,200 meters. Now, if you said west is positive, and I think I see why people would say that, because west is the bigger number. Right? Is that why you did that? Yeah, like that makes sense. Right, so then you're going to get a positive answer. Just would mean that you'd be negative 300 and positive 1,200, that's all. Time interval here is 1,800 seconds. We want to find the average speed in this question and the average velocity in this question. What's the equation for speed? Delta D, distance, over time. What's my distance traveled here, huh? What's my distance traveled, Marshall? Yes, yes. Be careful. Don't include the negative there. I wrote that down as a given because I didn't want to write down my givens twice. But I know that when I'm solving for speed, I'm using distance, and I have to drop the signs when I'm using distance. So it's going to be 300 plus 1,200 over 1,800 seconds. Okay, we solve that, and it works out to be 0.833 meters per second. Solving for average velocity, we're going to say displacement divided by time. My displacement is, do we add these or subtract these? Add them. If we have positions, we subtract them. If we have displacements, we add them. So we're going to say 300 plus negative 1,200. Wait a sec, didn't I say add them? Yeah, I'm adding them, right? I'm just adding a negative number. 300 plus negative 1,200. Delta T is 1,800 seconds. That gives me negative 0.500 meters per second. Hey, how come those two numbers are different? Change direction. I went north, or sorry, I went east and then I went west. What does the negative mean for B, the velocity? Yep, then I'm going to the west. What does the positive mean for A, for the speed, the 0.833? Nothing, because the speed is a scalar. Got it? Let's have a look at questions 5 and 6 that you've been working on now. Number 5 says a jogger runs 5 kilometers north in 25 minutes, then stops for a break for 10 minutes, then runs 10 kilometers south in 53 minutes. Calculate the jogger's average speed and velocity. Are these two numbers going to be the same or not? Sandra, how come? Right, so we expect to get two different numbers here because of the change in direction. Now, as I'm walking around, I mentioned to a number of you when you were solving these problems yourselves, make sure you show everything. Make sure you show all of those givens. Make sure you show the equations. The equations aren't just, this divided by this. It's the equation as it appears on our equation sheet. You might think like, well, I don't need to do that. I can get this right without showing all my work, without showing my givens and so on. You can imagine how, guys, this is day 3 of Physics 20. Okay, some of these questions are a little bit tricky right now. They get trickier. Okay, as we get trickier, that doesn't mean it gets harder for you because you become smarter as the course goes on, right? But as we get into more complicated questions, it becomes more critical to follow these good habits, right? And if we avoid getting into these good habits now for the easier questions, then we're going to be pretty much hooped when we get into the harder questions. So we want to make sure we get into those good habits now. Okay, what do we want to write down for givens for question number 5? Well, let's define north as positive here first. Something is 5 kilometers. What is that? Is that a position? Is that a displacement? Is that a velocity? What is it? Cam, what is that? Yeah, that's a displacement. I'm going to call it displacement number 1, right? Phase 1, displacement number 1. And it's positive because it's north. I'm going to say something's 25 minutes. What do you want to call that? Well, that's going to be a time, right? Just time? Let's call it time 1. And let's convert that to, what do you want to do? How many people did hours for this? How many people did seconds for this? Okay, 50-50. Let's go hours. Okay, it doesn't really matter. Let's go hours. 25 divided by 60 is 0.41667 hours. All right. Another displacement, we'll call that displacement, what do you want to call this? It's 10 kilometers, negative 10 kilometers. What do you want to call that? Displacement 2? I think I'm actually going to call it displacement 3. Anybody know why I did that? Yeah, there was a break in there, right? What's displacement 2 going to be? 0, right? Because we stopped for 10 minutes. Does the 10 minutes matter? Yeah, it does. Okay, if you want to determine your average speed between here and wherever, like, you got to account for everything, right? Including your stop time. I'm going to say this, time 3 is 53 minutes. That's going to be how many hours? 0.8833 hours. And I'm going to say time 2 is 10 minutes. I think that's 0.1667. Is that right? 10 divided by 60? Yeah. I don't need to bother writing down displacement 2 because it's 0, right? So far, so good? This is what we want you to write down. For every question, this is what we want you to write down. Now, I'm looking for the speed, the average speed, and the average velocity. The average speed is distance divided by the time. What's my total distance here? 15 kilometers, yeah. We're not going to pay any attention to the negative 10 there. It's just 5 plus 10 is 15. The time interval here is, we're going to add these up. 0.167 plus 0.883 plus 0.416, 1.467. Good? And I'll tell you in a second here, okay? 15 divided by that gives me, it's about 10. 10.2. Although, if we look at our significant figures here, that's 2 digits, that's 2 digits, 2, final answer is going to be 2 digits, which is 10 kilometers per hour. Now, in meters per second, that would be 2.8 meters per second. So if you did it meters per second, you should have gotten 2.8 meters per second. It would be 15,000 meters divided by whatever the seconds is. Good? How many people got that? You got 0.28? Then I think what you've probably done is probably converted distance wrong.
Oh, I did 1,500.
Yeah, so you converted distance wrong. Yeah. Okay, good. The average velocity here now for this one. It's almost the same, right? But as you said, we expect to get a different number here because we changed direction. What's my displacement going to be? Not 15. My displacement's going to be negative 5 kilometers. How come? Where did that come from? Yeah, we define north as positive, so 5 plus negative 10 gives me negative 5. My time interval here is, it's still going to be, oh, wait a second. Now I'm going south. Do we have to make time 3 negative 0.88? Cody? No, we don't, because time is, right. Even though my displacement during that time is south, my time is still a scalar, right? Not north, south, or otherwise. And that ends up giving me negative 3.4 kilometers per hour. 2 different numbers because we changed direction. In meters per second, that would be 0.94. There we go. 95, okay. I get 0.94 because I use my rounded number to convert, whereas, no, you should actually use your unrounded number. I just didn't know what the unrounded number was, that's all. Because I had written down my rounded number for an answer. Good. Okay, number 6, this is the trickier one here, I think. In fact, I know it's the trickier one. Car travels 90 kilometers per hour to the east for 10 minutes, then 100 for 30 minutes. What's the car's average speed and velocity? I don't know about you, but man, if I was in grade 11, I'd probably look at this and say, oh, that's easy. 90 plus 100 divided by 2. You want to find an average, 90 plus 100 divided by 2, right? It's probably what I would have done. I would have been wrong, but it's probably what I would have done if I didn't know any better. Why is that wrong? Yeah, Jack? Yeah, I travel for different amounts of time. Picture this. You guys have all been to Edmonton, or most of you have been to Edmonton. You know where it is, right? It's about 350 kilometers north from here. If you travel at 100 kilometers per hour on average, 100 kilometers per hour, cruise control set for 100 kilometers per hour, let's say, how long is it going to take you to get to Edmonton? 3.5 hours, right? The average speed is 100 kilometers per hour. Okay. Well, what if I drive at 100 kilometers per hour for a couple hours till I get to Red Deer, and then I stop at the gas station or convenience store to get a drink in Red Deer for 5 minutes? How fast am I going then? 0. And then I go back to 100 kilometers per hour on the highway. What's my average speed? 50? 100 plus 0 is divided by 2 is 50. Now, it doesn't make any sense, right? I was only stopped for 5 minutes. I was driving for 3.5 hours at 100 kilometers per hour. I was stopped for 5 minutes at 0 kilometers per hour. My average speed is not 100 plus 0 divided by 2. This is not quite as extreme as that, but it's the same idea. Because the amount of time that I was traveling at these two different velocities for is different, we have to do something else. First thing I'm going to do is write down some givens, though, and then I'll figure out what to do. I'm going to say my first velocity is 90 kilometers per hour. You want to go kilometers per hour again for this? You want to go meters per second? Okay, my answer key is kilometers per hour here, but we'll just do this in meters per second as we go here. 90 kilometers per hour is 25 meters per second. 90 times 1,000 divided by 3,600. Delta T1 is 10 minutes, which is 600 seconds. 10 times 60 is 600. Good? I'm going to say V2 is negative 100 kilometers per hour. Negative 100 kilometers per hour is negative 27.7778 meters per second. 100 times 1,000 divided by 3,600 gives me negative 27.7778. My time interval here is 1,800 seconds. Looking for average speed, looking for average velocity. You guys remember the equation for speed? What is it? Yeah, you know what, honestly, like, it's funny we say that it's delta D over delta T. The equation is actually distance divided by time. We only represent it by delta D over delta T, but that's what we're using, right? Okay, we're saying delta D stands for the total distance divided by the total time. We don't know what the total distance is, do we? So let's find it. Let's say distance 1, or let's actually get displacement 1, is velocity 1 times time 1. So I'm going to say, what is that, 25 meters per second times 600 seconds. I don't know what that is because 1,500? 15,000? For sure? Okay, 15,000 meters. You know it's meters because the seconds cancel, right? Delta D2, displacement 2, is V2 times T2. What is this now? Negative 27.7778 times T2, which is 1,800 seconds. What is it? Say it again.
50,000.
Exactly? Okay, if you use the unrounded number, it's exactly 50,000. Okay, so negative 50,000 meters. You know we used to put commas in for numbers, right? You know that that's like not accepted anymore? Do you know why it's not accepted? Yeah, because of the French math. Everybody uses commas for decimal points, right? So we don't want to get mixed up. So listen, I'm not going to mark you wrong if you put a comma in for 50,000, but technically we're not supposed to do that anymore. All right, so what's next? Yeah, we got to find the average speed, which is the distance divided by the time. The distance traveled here is going to be 65,000 meters, right? 50,000 plus 1,500. The time interval is going to be 2,400 seconds. What did that work out to be? 0.66. No, we don't want hours here, right? We're keeping seconds. 65,000 divided by 2,400. Yeah, okay, to 2 digits. 2 digits right there. We're going to say 27 meters per second. Good. Average velocity is going to be a different number because we switched directions, right? Displacement divided by time Displacement is, well, what are we going to say, 15,000 plus negative 50,000 over the time interval of 2,400 seconds. We don't need to worry about the fact that one is to the west as far as the time goes. Times are both positive. What's that, 15,000 plus negative 50,000 divided by 2,400 gives me negative 14.58. But we're going to round that to 2 digits. The third digit is a 5, so we're going to round it up, yeah. Third digit is 5 or greater, we round the second digit up, which gives me negative 15 meters per second. Or you could have said 15 meters per second to the west. Good? Is comfortable with that? Okay. We got another few minutes here, but